Okay, we're back. This is AP Physics 1, check-in number 2. We're going to talk a little bit about projectiles. Got a couple questions. If you want to stop the video, pause it, and try it. Otherwise, take a look at your answers and my solutions. This problem, as you can see, starts with an object that's shot horizontally, a box flying off a table that has a height of 0.95 meters. Velocity in the x direction is 2.4 meters per second. And you want to find out what is the time in the air, as well as how far it goes horizontally, what is the range. So pause and then try it. The way in which you solve this problem is to try to figure out what's happening in both directions. And now I'm not sure if you remember this, but we sometimes decided to fill out a little chart to determine what was happening in both the x and the y directions. So first we'd say V naught, maybe A, what was happening with the displacement, and what is happening with the time as a function of which direction you're at. In the x direction, we said the velocity was 2.4. In the y direction, it's 0. The acceleration in the x direction is always 0, and in the y direction, 9.8, negative 9.8 if you use that as your direction, positive versus negative. We don't know how far it is in the x direction, but we do know in the y direction it's falling down a height of 0.95 meters. The time is the one scalar quantity that once we find in one direction, we'll have in the other direction. So if you look at this, we only have two variables that we know in the x direction, and we have three things we know in the y direction. So I think I would use the kinematic formula delta y equals v naught t plus 1/2 a t squared to solve for the time in the air. The v naught in the y direction is 0 because it's coming off of the thing horizontally, coming off the top horizontally. Therefore, it's not moving vertically. Therefore, this quadratic equation is a little easier than you might have imagined. If I look at that, move the 2 to the other side, I'm going to have 2 times that vertical displacement, divide by the acceleration, see if you agree with that equation, take the square root. So if I put in some numbers, I'm going to take 2 times negative 0.95 meters, and then I'm going to divide by negative 9.8 meters per second squared. If I do that calculation, I'm going to get 0.44 seconds. And the next step would be to solve for B is how far does it go horizontally? That's a pretty straightforward equation because you remember that as far as the x direction is concerned, you only have one equation because the acceleration in the x direction is 0. Everything kind of drops out for you. So all I need to do is take my 2.4 meters per second and then multiply by what the time in the air is, which I just got 0.44 seconds. And I find that it travels 1.06 meters, excuse me. So that is how far it travels. Hopefully that problem made sense. We're just trying to review problems from easy to hard. Let's go on to the next one. See if you can figure out what's going on with this one. It says the ball is thrown 8 meters per second at an angle of 25 degrees above the horizontal. So here's our picture of what's the initial conditions. And then it says draw a picture showing how the velocity vector changes as a function of time. Well, the idea is that we know that it's just going to take a parabolic arc to it. So as it travels, it should look something like that. But what happens to the velocity vector? Well, it's got an x component and a y component. At the beginning, it's got a y component initially like that, whereas its x component is right here. As we go through, it's got a y component at this point, but the y component is very small at that point. Still got the same x component, but the overall velocity has been reduced. At the top, it's got just an x velocity, no y velocity. Excuse me. As it goes down, it again has the same x velocity, but has a small y velocity, but it's downward. So the idea of that question is draw a picture showing the velocity changes. It's going to go from a high value to a low value to 0 in the y direction, and it's going to start to get bigger in the negative direction. At the bottom, if you remember correctly, when it hits the bottom, it should have the same x velocity as it did before, because it's always going to, but its y velocity should be the same as what it originally was over there. So that was the purpose of that question, was to just take a look at how the velocity changes. The next question is, where is it located at t equals 5 seconds, or half a second? So then you can go ahead and just calculate. It wants to know x and y. Well, delta x, again, is a pretty straightforward calculation. It's v naught x times t. Well, you would have to calculate what v naught x and v naught y are. And remember that you take v naught as 8, and you multiply by the cosine of the angle of 25 degrees. That's the cosine of 25 degrees. If you do that, you get 7.25 meters per second in the x direction. So that's v naught x. V naught y is going to be that same number, 8.0 times the sine of 25 degrees. When I do that calculation, I got 3.38 meters per second. So v naught x is 7.25 and v naught y is 3.38. In this case, then at half a second, then I'm going to take that x velocity, 7.25, and I'm going to multiply by a half a second. And it tells me that it's 3.63 meters in the x direction. That's how far it's traveled. In the y direction, I'm just going to show you the equation, v naught y t plus 1/2 a t squared. Remember that you have to put in a negative 9.8. But if you do that, I'm just going to tell you that you get 0.465 meters in the y direction. It will be above where it started, which gives you a positive y displacement. Okay? The third part to that was to find out what the overall velocity at a time was. And maybe I'm just going to give you some results, but the overall velocity should be the x component squared plus the y component squared, take the square root. To find the y component, we're going to have to take the initial y component plus the acceleration multiplied by time. And if you do that, I got that you ended up being a negative 1.52 meters per second, so it's on its way down. And then when I put in my initial x direction velocity of 7.25, square it, plus a negative 1.52 squared, take square root, my overall velocity turned out to be 7.41 meters per second. I hope you can go back through, stop the video, and prove to yourself that those are the answers that you're going to get. And then the last question that I have for you is to try to see if we can figure out whether this thing is going to make the goal. This soccer ball is hit at 12 meters per second at 35 degrees, and you're hitting it to a goal. A normal soccer goal is 2.44 meters. That's the height, and it's 8.5 meters away. And the question is, do you think it could be possibly good or not? And so I'm going to give you some ideas of whether or not that makes sense. Okay. Again, let me get that down. Sorry if that wasn't completely in the picture. Trying to find out whether or not this soccer goal is good. Here, I need to find the x and y components. This is going to be 12 cosine of the angle, 35 degrees. If you do that, I got 9.83 meters per second. And then the y component is 12 meters per second sine 35. And that's 6.88 meters per second. Okay? Straightforwardly, if I know what the y velocity or the x velocity is, I can work in the x direction to find out, if I go delta x over v naught x, to find out how much time it takes to get to that goal. So I'm just going to take my 8.5 meters and my 9.83 meters per second, and that's going to tell me how much time it took to get to that spot. 0.865 seconds in the air. Seconds. Okay? At first this problem may look difficult, but then all you have to do is, let's find out using the v naught y t plus 1/2 at squared equation. Plug in your numbers and find out whether or not it makes sense that it's good or not. So I'm going to put in these numbers 0.865 seconds. And I'm going to put in 1/2 negative 9.8. And then I have to have that 0.865 seconds quantity squared. And what I get is 2.29 meters is where it's located in the y direction. I'm going to say that as long as the goalie doesn't touch it, it looks like it could possibly be good. Okay. I hope that was useful. Stay safe. We'll catch you next time. Thank you.